So UART is Universal Asynchronous Receiver Transmitter, and this type of frame is used to transmit a data. Since it is asynchronous transmission, the clock is not transmitted along with data. So for synchronization purpose, we have to use this type of frame. There is a start bit. So generally logic 0 is used as a start bit. Then you can transmit the data. We use a 8-bit data frame, but it can be 7-bit also. So we are generally using ASCII code. So we use a 8-bit data, and then there will be a stop bit. You can select number of stop bit, one stop bit, 1.5 stop bit, or 2 stop bits can be transmitted. Along with this, sometimes the parity bit is also transmitted before this stop bit to check whether data is received properly or not. So we'll discuss this UART block of LPC2148. So in LPC2148, it has two inbuilt UART blocks, that is UART 0 and UART 1. So we can connect two UART enabled devices to these two blocks. So generally this is used to interface GSM module, GPS module, Bluetooth module, where we want to perform a communication through UART block. That means we want to perform serial communication. So these UART blocks can be used for interfacing GSM module, GPS module, or Bluetooth module. So two UART blocks are available here. This you have to remember. Now the features of UART block 0. Two UART block means the first block is called as a UART 0 and second block is called as UART 1. The few features are listed here. 0 is having receiver and transmit FIFO. That registers are there, or the buffer registers are there, which will act as a receiver register and transmitter register. These are the FIFO register, first in, first out register. Then it is having built-in fractional baud rate generator. So we can program the baud rate frequency. Baud rate can be programmed here. So that block is available internally. Then software flow control through TXEN, transmitter enable bit, in transmit enable register. So you can control the flow of data transmission using this bit in UART 0. Whereas in UART 1, same receiver and transmitter FIFO, that first in, first out type registers or memory is used there. Then it is also having built-in fractional baud rate generator. Then here the software and hardware flow control implementation is possible. That means to control a data flow, you can use hardware technique also in UART 1 that is not available in UART 0. In UART 1, additional feature is that you can interface modem, and all modem controls are available in UART 1. With UART 0, modem control signals are not available. As you know that in RS-232, only 3 terminals we are using, that is transmit terminal, receive terminal, and ground terminal. All other terminals are related to modem interface signal. So that signals are available in UART 1, which are not available in UART 0. So next is register. So you have to write a program for data transmission serially using UART, or receive a data serially using this UART block. Actually, this is your practical program also. So let us see the registers one by one. These are two important registers. The transmit pin TX. To this pin, these two registers are associated. THR register, which is transmit holding register, and TSR register, which is transmit shift register. So the arrangement is like that. First, there will be a TH register. So here this is, or directly I'll write HR register, that is transmit holding register, and this is connected to this register TSR register. So here shift register. So what we have to do, user will store data in THR register. So here we'll store ASCII value of character which we want to transmit serially. Internally, this parallel 8-bit ASCII value will be converted into serial, and that will be stored in shift register. The shift register will transmit this 8-bit serially, that is 1 by 1 bit at each clock signal. So user is going to store ASCII value in holding register, and automatically the controller will convert it into serial data, and that will be transmitted. So for this, these two registers are used. Then for receiver pin, two receiver registers are associated, that is RSR, receive shift register, and RBR, receive buffer register. So whenever data is received, that will be stored in RBR register. Sorry, whenever data is received, that is stored in receive shift register. So that will be converted into parallel, and then it will be stored in RBR, receive buffer register. So when we want to read received 8-bit data, we have to read this RBR register. So that will be first received here and will be converted into 8-bit and stored here. So these are the 4 registers associated with this pin. The 2 registers related to transmission of data, and other 2 registers related to reception of data. The next register is U0LSR, that is UART0 line status register. Now only important bits I have shown here. Other bits are also there, but we'll use these bits only. So the first bit is THR bit. Here you are observing that bit is 1 if data is transmitted completely. So after transmission of one character, automatically this bit will be stored 1. So what we'll do in program, we'll transmit one character, and we have to check this THR bit continuously, whether it is 1 or not. If it is 0, that means data is transmitting, but if it is 1, that means data transmission is completed. So what we have to do in program, we'll read this register, line status register we have to read, and we'll check whether this bit is 1 or not. For that, as you know, we are using a masking technique. So we'll read this data from register, we'll AND it with this data. So this bit, we are interested only this bit while transmission of data. So this bit will AND it with 1. All other bits will AND it with 0. So we'll AND the data with 20H. If result after addition operation, if result is 20H, that means this THR bit is 1 and data is transmitted completely. You can transmit a new data. This is for data transmission. Similarly, for data reception, RSR bit is used. So when the 8-bit of data is received completely, this bit is automatically set to 1. So how we'll check whether data is received completely or not? Again, we'll use a masking technique. We'll mask with 0, 1. Now we are interested only in this bit, not this transmission bit. So we'll AND it with 0, 1. And if result of AND operation is 0, 1, it indicates that the character is received. And now we can read that character. So this logic will use while transmission of data and reception of data. Next register is FIFO control register, that is U0 FCR register. So again only important bits I have shown here. So here this last bit LSB bit is to enable the FIFO. So all this FIFO we have to enable to logic 1. Then this receiver FIFO should be reset so that all the data stored in receiver FIFO will be cleared, and to reset a transmitter FIFO, that buffer, this bit should be stored as 1. So initially we'll enable this FIFO, we'll reset receiver FIFO, we'll reset a transmitter FIFO. So in this register we have to store 07H data. That is, in control register we will store 07H data. The next register is U0 LCR register, that is UART0 line control register. So this is LCR register, as you can observe here. This is U0 LCR. So again only important bits we are going to initialize. All other bits value will use as a default value. That means there is only one stop bit, and that stop bit is 0. But this value we are going to change. We want to transmit 8-bit character, that is ASCII value of character we want to transmit. So these two bits, bit number 0 and 1, should be initialized with 1 1. So we'll store here 1 1, and you will get U0 LCR as 03H. So that is to select the your frame of data transmission. Start bit, then 8-bit character, stop bit. Other bits are also available there, but we'll change only this bit. The next is pins used for UART0. So P0.0 is used as a transmitter pin for UART0. The function you have to select is 01, that is in pin cell 0 register. So if for these 2 bits of pin cell 0 register will store 01, then we are using this pin as a transmitter pin. P0.1 is used as a receiver pin. So in pin cell 0, pin select 0 register, we have to store 01 to use this pin as a receiver pin. So we'll initialize pin cell 0 register like this. These 2 pins are for transmission pin, and these 2 bits are for reception. So we have to store this value 05H in pin cell 0 register. Now let us understand program. Here LPC2148 header file we are including. Here UART.h file should be included, which will compute a baud rate calculation. That calculation we are not going to discuss here. So you have to include this file UART.h, which will perform the calculations for baud rate. So if you want to use delay in program, you can write a delay function. Here only 1000 count we have stored to generate a delay. Then we'll start a main program. Here this numbers are in variables are initialized, like data and I variables, which we'll use here. I am going to transmit a KKW string. You can transmit any string. According to length of string, you have to change digit here. So we are declaring here an array with some characters. Now we'll start initializing register. So first we'll select the function of pins. P0.0 and P0.1. So this pin cell 0 register should be initialized with value 0x05. Next is we'll decide the direction of this pin. So RX pin we are going to use as a input and TX pin we are going to use as a output. In this program, we'll write both functions for transmission of data as well as for reception of data. You can write a separate program also. Then you have to initialize this FCR register to reset the FIFO to enable the FIFO. So as we have discussed, we have to store here 07. Then line control register U0 LCR. The data bits we are using 8. There is no parity. By default, no parity is there. So we are going to store 0 for all other bits. Stop bit is 1. So this should be initialized with 03. Next is baud rate 9600. So this baud rate calculation for 9600 are included in UART.h file. So that file we have included. So this baud rate is a function written in UART.h. So according to this baud rate, it will do a calculation for decision of the frequency which will be used for this UART block. So that directly we are using here. So we are calling this function baud rate 9600. Then next for loop we have used as per the characters in your string. So there are 3 characters in this string. So we'll start this I from 0 up to 2. This data is the variable we have declared, and we'll read a first character, and ASCII value of this character will be stored in variable data. Now when you store this in data, it will start transmission of this, or this data you have to store in holding register. That is missing here. I'll explain it afterward. But after data transmission, we have to check the FIFO bit. That register is empty or not. So that is in U0 LSR. So in U0 LSR register, we'll read that register and we'll AND it with 20. So after this AND operation, if it is not equal to 20, that means it is not empty. So continuously it will execute this while loop. If it is equal to 0x20, then it will come out of this while loop and you can transmit the next data. So actually here what is done, first it is checked whether the previous data is transmitted or not, and after that if previous data is transmitted, this transmit holding register, this data character is stored in transmit holding register. You can modify this. You can write this instruction here. We'll assume that initially this transmit holding register is empty, and after that you can check whether data is transmitted completely or not, and then you can transmit the next data. So here it is first check and then data is transmitted. So that also can be done. After that, this again it will check transmitter next data, or you can exchange this instruction. Then for transmission of next data, here delay is written. No need of delay also, because we are checking this register whether the data is transmitted completely or not. But you can add delay also. So this is the program to transmit data. We are transmitting one character at a time. Now we can write a function for reception of data. You can write a separate program also for reception of data. Here both functions are written. So first again here this LSR register is checked. That means that receiver register is checked whether it is empty or not. So for that this LSR is ended with 0x01, and if it is uh, if it is 1, then it is continuously executing this. Otherwise it will store this received data in the data variable, and that you can read afterwards. So this is the reception program.